Welcome! In this video we will explore how to create animated hole effect in Jetpack Compose. So as you can see here on the demo, we can drag the slider and progress the animation, or we can just click somewhere on the topmost image and it will play the animation from the position where we click. So if you're excited, let's dive into the code. So we start with defining a class called CircularHoleShape, and this class takes two parameters in the constructor. So the first one is a private value progress, which is a float value ranging from 0 to 1, which defines the size of the hole. The second parameter is another private value, center, of type transform origin. So this is a center from which the hole will expand, and by default it equals to transform origin center. Also, this class implements a shape interface, and we need to implement a create outline function. But before we implement this create outline function, we need to define a utility function which will calculate a straight line distance between 2 points. So we define private infix function. So this is an extension function for the offset named distance2 other offset, and it returns a float value. So to calculate this distance, we use a hypot function, and here we need to paste a differences between the x and y coordinates. So other x minus this x and other y minus this y. Alright, now we can implement this create outline function. We'll remove this to do, and first thing we need to turn the size into a rectangle. So we create a value rect size to rectangle. Then we need to check if the progress equals to 0, which means no hole effect is applied. Then we want just to return an outline rectangle with a rect bound. If the effect is applied, then we need to calculate the center of the hole. So we define another variable hole center. And this is an offset. And to calculate the center, we use our center parameter pivot fraction x multiplied by size width, and center pivot fraction y multiplied by size height. Now we need to calculate a target radius for the hole, which is the longest distance from the hole center to any of the corners. So we define our value target radius, and to define the longest distance we use max of function, and now we use hole center, our distance2 function, rectangle top left, and we repeat the same for the rest of the corners. So top right, bottom left, and bottom right. Alright, now that we have our target radius, we can calculate our current radius, which depends on the progress. So we define a value called radius, and we multiply our target radius by progress. So the way we will achieve the effect is by subtracting the hole path from the rectangle path. So we need to define those two, and we start with view rectangle path. Value view path. This is a path at rectangle rect. And now we define the hole path. This time we add an oval, and we need to create a rectangle with hole center and hole radius. Now we need to create another path variable which will hold the subtraction result. So we'll just name it a path. And to perform the subtraction, we use op function. So first we paste view path, then hole path, and the path operation we use difference. All right, finally we need to return an outline, generic, and paste the path. All right, we are done with our shape class, and you can already clip any view to this shape. However, to make it more convenient, let's create a custom modifier for that. So we define an extension function for modifier, and we name it hole. So this function takes the same parameters that the shape class does, but we need to remove these keywords. All right, we can now apply a clip modifier and create a CircularHoleShape class instance with progress and center. Alright, now with that function we can easily clip any composable to the shape. However, to bring this animation to life, let's create another modifier function. This time we name it HoleAnimation. And this function, instead of the progress, takes isVisible boolean, which determines whether the content is currently visible or not. It also takes a center. Then we also need animation spec of type float. And the default value is a twin animation with 700 milliseconds duration. And the last parameter is on finish lambda. So this is an optional lambda, and by default it's null. Also, this function returns a new modifier. And since we want to use an animator state, we need to annotate this function with composable annotation. Now we can create our progress animation by animate float as state. If content is visible, then the target value is 0. And if the content is not visible, then the target value is 1. We also import that. Specify the animation spec. Also give it a label. And finally, in finished listener, we get a current value. And if onFinish lambda is not null, then we invoke this lambda and check whether the current value equals 0. And finally, we just return this modifier with all modifier applied. Use our progress animation and center. Alright, we are done with our functions, and now we can jump into the main activity and explore practical examples. Alright, we are in the main activity, but to implement the animated example, we need to define another utility function which will detect origin of the click position. So we define an extension function for modifier. We name it detect top with origin. And this function has one parameter. It's on top lambda. And we use this pointer input unit. We utilize detect top gesture. And first we need to get an click offset. Then we need to calculate an origin of the click. So for that we define origin value, just transform origin. So to calculate the pivot fraction x, we need to divide the click offset x coordinate by size width, and we do the same for y. And this time divided by height. And finally, we invoke on top lambda with our origin. So we can get back to our examples, and we start with the animated one. And for that, we need two state variables. So the first one is a var HoleCenter. Transform origin center. We import get and set value, and another state variable is visible, and this time it's a boolean value, which is true by default. Now I will use an image composable for the demonstration. So painter resource r.drawable, and I have this doc image included in my drawable resource directory. So you can either use your own image or you can use any other composable. It should work as well. The content description is doc image. And finally, we apply our modifiers. So the first, we detect the top with origin. We receive tap origin. First, we update the HoleCenter with a new origin. And then we trigger the animation by changing the isVisible state to an opposite. And finally, we apply the HoleAnimation, isVisible, and HoleCenter. All right, we are done with our animated example. Let's create a manual one. For manual example, we need another state variable, progress. It's immutable, float state variable with 0f by default. And I will use the same image here, just instead of those two modifiers, I'll use a hole modifier with progress specified. And to change the progress, we need a slider. Progress equals it. And also I would like to set a fixed width for this slider. Let's say 300 dp. All right, we are done with our examples, and let's launch the application and take a look at what we've built. All right, the application has launched, and as you can see, it works. And this is a really beautiful animation. So if you enjoyed the video, please hit the like button down below and subscribe for my channel, and I will see you in the next video.